In this video, we're going to explore the world of common factors. All right. So by the end of this video, you should be able to basically common factor monomials, binomials, or factor by grouping. Okay, let's take a look at our first learning goal. Actually, I changed my mind. Before we do, we need to understand the difference between factoring and expanding. Okay, so let's make a quick note here. Factoring is the opposite of expanding. And the way that I like to show this is with this little graphic here. So we have x squared plus 3x is equivalent to x times x plus 3. Okay, so when we're going this way, we are factoring, and this way is expanding. You can think of factoring like condensing it, and expanding here would be us multiplying by everything to get rid of the brackets. Okay? So when we're factoring, what we want to do is kind of follow the same steps every time. And one of those first steps that we're always doing is we're asking ourselves, is there a greatest common factor? That I can pull out and work with. So let's just jump into an example, because I think once you see it happening, it'll be a little bit easier. So let's say I have 6x plus 3. So the question here is to factor fully. So how do we factor this? The first question we have to ask is there something that's in common between these two? Is there anything in common with my coefficients? Is there anything in common with my variables? Let's take a look. Okay. So if I look at my coefficients, I have 6 and 3. I know that there are numbers that can go into 6 and 3, and the greatest common factor of 6 and 3 is 3. So what I can do is, quote unquote, pull out a 3 from the both of them. If I pull out a 3 from the both of them, it's like I am dividing each of them by 3. So I'll just draw that underneath here so you can visualize it. So if I divide both of these by 3, what am I left with inside my brackets? Well, 6x divided by 3 is going to give me 2x, and 3 divided by 3 is going to give me positive 1. So I have just factored this. If you want to expand it, you can go ahead and apply. Will you get the same answer? Let's do it. 3 times 2x equals 6x, and 3 times positive 1 gives me 3. All right, so let's try another one. Let's use one that's a little more tricky, okay? Let's try this one. 25k to the power of 6 plus 15k to the power of 4. So I'm trying to pull out something that they have in common, but the greatest something they have in common, the greatest common factor. So let's start with my coefficients, okay? So 25 and 15, what is my greatest common factor for 25 and 15? That means, what is the biggest number that can go into 25 and 15? Well, that number is 5. Now, I also have to look at my variables. Is there a greatest common factor amongst my variables? it doesn't work the same way as it does with coefficients. When you're looking at your variables, you want to ask yourself, what do both of them have the same amount of? So I know that I have 6k's over here and I have 4k's over here. So they both definitely have k, but how many k's do they both have? They both have 4, right? I know I've got 6 over here, 1, 2, 3, 4, 5, 6, and this one has 1, 2, 3, 4. So I know I can take 4 from here, and I can also take 4 from here. And now we're going to see what's remaining. I know that if I... So let's do the same thing we did in A, which is divide. So first I'm going to divide my... Let's do the coefficients first. 25 divided by 5 is 5. Okay, and then I'm going to leave some space. And 15 divided by 5 is 3. Okay, now what am I going to do with this k to the power of 6 and k to the power of 4? Well, I'm also going to divide. I'm going to divide, it's going to look like this. Right? So I already did my 5 and 25, and I already did my 15 and 5. So when I'm dividing, you need to know the rule for, oh, it's not showing. My apologies, let me get that up. My apologies for the technical difficulties. The iPad is fighting me as usual. Okay, so I was just writing this over here. I was showing you how we're dividing by the greatest common factor. So we're dividing everything by 5k to the power of 4. So I did the coefficients first. I'm just breaking it down step by step so you can see. And now when we are dividing using exponents, we're actually subtracting. So that's a rule that you need to remember, okay? So what I have left here is 6 minus 4 is k to the 2. And then I have k to the power of 4, and I have 4 minus 4, so cancels out. That's my final answer. You've just factored that. Let's try one more with variables in it as well so we can pull out the greatest common factor. I wonder if I have enough space here at the bottom. Let's try. Okay. Let's do 21c4d3 minus 28c2d5 plus 7cd. All right, that looks like a doozy. We have to ask ourselves, is there a greatest common factor here? What is the greatest common factor between all these terms? Let's look at the coefficients first. I see 21, 28, and 7. So I know that I have a common factor, and that common factor is 7, and it's also the greatest common factor. So let's go ahead and pull that out in front of the brackets here. But now I need to look at my variables. I have C4D3, C2 and D5, and C and D3. So what amount from each of those variables can I pull out and take? Well, I look at the C's first, C4, C2, and C. The maximum amount I can take is C, because this one here only has one value for C, right? It's technically C to the power of 1. Let's look at our variable for D. I have D3, D5, and D3 again. Well, I know that I can take out 3, right? You can just think of using the dots like I did in question B if that's helpful for you. So if I remove this from all of these terms. So if I divide all these terms by this greatest common factor, what am I going to get? So we can write it out over here on the side. So I have 21C4D3. That's going to be divided by 7CD3. So what am I left with? Well, 21 divided by 7, that's going to give me 3. And then I have C4 divided by C, which means subtraction, right? So I'm going to do C4 minus C. That's going to give me C3. And then I have D3 divided by D3. Well, that just cancels out. Okay, let's continue here. Then I have minus, let's erase this here so we have a little more space. So now I have 28 C2D5 divided by 7CD3. Okay, so what is 28 divided by 7? 4. Okay, C2 minus C is going to leave me with just C. And D5 minus D3, we're dividing, so we're subtracting the exponents, right? It's going to leave me with D2. And let's do the last one. And then I've got 7, whoa, that's a weird 7 for me to draw, 7CD3 divided by 7CD3. Well, what is that? How many times does 7 go into 7? It goes in once, right? How many times does C go into C? It goes in once. How many times does D3 go into D3? It goes in once, so we represent that with a positive 1. Now, what if we have a question that looks like this? Let's say we have 5x5 y3 plus 7 w to the 5 and z2. Is there a greatest common factor here that I can take out in my coefficients? No. And do I have any variables in either of these terms where I can also pull out a greatest common factor? No, because all my variables are different. So it's possible that you might see a question that is not factorable. And that's okay. You also may see a question that looks like this, where there is no greatest common factor of the coefficients, but there is a greatest common factor of your variables, right? There's no number that goes into 8 and 7 equally, but I do see that I have an x term in both of these. So what I can do is take out an x from each. So I'm going to divide by x. So I'm going to take my x outside the brackets, right? We can draw it over here. 8x squared divided by x. That's just going to give me 8x. And then if I want to do 7x divided by x, well, that's just going to give me 7. If you don't want to divide on the side, you can also visualize I'll just draw this again down here. Once you pull out that greatest common factor, you can just ask yourself, x times what is going to give me what I need inside the brackets to match what I started with. So I know x times 8x is going to give me 8x squared when I expand it. And I know x times 7, negative 7, is going to give me negative 7x when I expand it. So that's another way that you can think about it as well. Just use whatever method works best for you when it comes to the visualization of factoring whatever you're working on, whether it's a monomial, binomial, etc. Okay, let's look at a binomial common factor. So we've got, let's do this one, 3x times y plus 1, and then I've got plus 7z y plus 1. So when you're looking at this, you can think of y plus 1 as one factor. The greatest common factor here is actually y plus 1 because that's what both have in common. So what you do is very simple. You just take the y plus 1 and you write it out front in the first set of brackets, and then you look at your remaining terms. So I have 3x and I have positive 7z. So all I'm going to do is, in my next set of brackets, is write 3x plus 7z. It's as simple as that. Let's try one more. Let's say I have 2x, and I have x times x minus 3 plus, let's do minus 5x minus 3. Well, how do I factor this? I have to find the greatest common factor that these two share, and that just so happens to be x minus 3. So I'm going to go ahead in my first set of brackets, I'm going to do x minus 3, and I'm going to look at my remaining terms. I have 2x, and I have negative 5. That's it. You've just common factored binomial. With a binomial common factor, I should say. The common factor is the binomial. Now let's factor by grouping. So often there's no common factor for all the terms in a polynomial, but there's some terms that have a common factor that can be taken out. So you can factor by grouping sometimes. So what we're going to do is factor group terms first instead of factoring the entire polynomial. So let me show you what that looks like. Let's say we have, let's not work with any numbers just yet. Well, we'll work with some small numbers. Maybe it'll help you see it better. So when we factor by grouping is that we're going to group terms together that have a common factor. So I see that I have a common factor here, and that's a. And I also see that I have a common factor over here, and that's 2. So I'm going to group these together, and I'm going to rewrite it. It just happened to be in order for us, which was nice. So let's just rewrite it. Okay, so I have ax plus ay, and then I have plus 2x plus 2y. So what is the greatest common factor that I can pull out of each of these terms? Let's look at the first set of brackets. Well, I don't have any coefficients, so I'm going to look at my variables, and I see that I can pull out an a. If I take out an a, I know that I'm going to be left with x plus y, right? Because if I were to expand this, I'd be brought back to this. Okay, let's look at the next set of terms I have here. I see I have 2x plus 2y. Well, I see something in common with both of those, and that's a 2. What am I left with? If I divide by 2, I get x plus y. Now, I know we just did the examples for the second learning goal, but you should notice that now that we've factored by grouping, we have a binomial common factor between these two. Do you see it? I have x plus y and x plus y. So I know that in my first set of brackets, I can write x plus y. And in my second set of brackets, I'm going to write my remaining terms. I have a, and I have positive 2. There you go. You've just factored by grouping. Let's try one more. All right, we've got 9x squared plus 15x plus 3x and plus 5. Okay, so let's take a look at how we can find the GCF for this. I didn't do this in the first one. The first one could have been done a second way as well. So there's not only just one way to do it. So for this one, let me show you both of the ways. So let's say that I decide to keep this in the order that it's in. Okay, so that means I'm going to keep it this way. I'm going to keep it with 9x squared plus 15x plus 3x plus 5. Okay? Actually, you know what? I'm going to move it over because I'm going to try to show you both of them beside each other. I'll just draw a little line here to help me stay. Whoa. There we go. Okay, so I've got 9x squared plus 15x, and then I've got plus 3x plus 5. Okay, so this is how I've decided to group things together. So if I look at my first set of terms in the brackets, I'm going to ask myself, what's the greatest common factor between my coefficients? I can see that it's 3. That's the biggest number that goes into 9 and 15. And I also see that I have a greatest common factor between my variables, and I can see that I can pull out an x. So I've got 3x. Okay, so if I divide everything in there by 3x, I can do it maybe down here at the bottom, right? We remember how to do this? Okay, 9 divided by 3, right? And then x squared divided by x, I'm actually subtracting. And then you can do the same thing for the 15. Sometimes I like to divide. Sometimes I just ask myself, what do I need to go from 3x to 15x? Well, I know that I'm going to have to multiply by 5. Okay. Lovely. Okay, so now I'm going to look at my next set of brackets. What can I pull out from my coefficients? Is there a number? Technically no, but just so you can visualize it, we're going to put a 1 here. Okay, that is technically what I can pull out from my coefficients. And I know if I have a 1 here, in order to get to 3x, I'm going to have to multiply by 3x, and in order to get to 5, I'm going to have to multiply by 5. So what I've just done is I have created a binomial common factor here. Do you see it? So when I see that I have my binomial common factor, I know that I write it in my first set of brackets, and then I look at my remaining terms and I write those. Okay? And now you've factored by grouping. But what if we wanted to factor this by grouping in a different way? Which might have been what you noticed initially. Which terms can I group together that seem to be a little more friendly? Well, I can group together 9x squared and 3x, and I can also group together 15x and 5, because in my mind I'm already seeing some common factors. I know that between the 9x squared and the 3x, I can take out a 3x, and that's going to leave me with a 3x plus 1. And then over here, I can take out a 5. If I divide everything in the brackets by 5, I know I'm left with a 3x and a 1. So you've done the same thing again. You've created a binomial common factor here, right? So I'm going to take my binomial common factor and write it in my first set of brackets. And then I'm going to see what my remaining terms are. 3x and plus 5. There you have it, factoring by grouping. So when you're factoring, you got to look at what you're dealing with. You have to ask yourself, should I factor by grouping first? Can I group these terms together? And then if not, you're going to ask yourself, is there a greatest common factor? You can start there. So if I'm factoring by grouping, I'm going to say, what am I grouping together? What's the greatest common factor? And then I'm going to factor. If I'm just factoring without grouping, you always start with, is there a greatest common factor amongst these terms? If so, what is it? Can I pull it out in front of the brackets and then continue my process? That's it.